right, so now we have notes on application of scientific notation. The previous notes just gave you an overview of what scientific notation was, how you wrote it in standard form and scientific notation form, how to go between both. So on this one, you actually have to solve. So we're just going to focus on multiplication and division right now, as scientific notation, and then eventually we'll move on to addition and subtraction, okay? So on number one, you have 4 times 10 to the third power times 2 times 10 to the second power. So both of those are in scientific notation, okay? So we're going to do it 2 ways. We're going to do it where you can convert it into scientific notation, from scientific notation to standard form, and then solve it, and then also leaving it in scientific notation and solving it. So you're going to have to choose which one is better for you, okay? So here we go. Convert 4 times 10 to the third to standard form. So that means I'm going to take this 4 and just do it over here to the side. Remember, when it's no decimal, your decimal is in the back. It's a positive 3, so that means I need to move my decimal 3 times. 1, 2, 3. 3 empty humps mean 3 zeros. So when I convert 4 times 10 to the third to standard form, that is 4,000. Okay. Convert 2 times 10 to the second. So I do this right on top. 2. Decimal is in the back when it's no decimal. Positive 2, so that means I move 2 times to the right. So that is 200. So standard form is just really in regular number notation, how we see numbers every day. Scientific notation is like this. We put it in scientific notation to notate really small numbers or really big numbers. But that's not how you see numbers every day. Every day you see numbers like this. So this is called standard form. So now that we have converted to standard form, they want us to write the answer in scientific notation. So the first thing we have to do is multiply our 2 numbers. So we're multiplying 4,000 times 200. So get your calculator and you'll multiply that. And when you multiply it, you will get 800,000. Okay, 4,000 times 200 is 800,000. So that's what we did. So 4,000 came from 4 times 10 to the third. 200 came from 2 times 10 to the second. Multiply these together, you got 800,000. Now they want us to write the answer in scientific notation. So they want us to go from standard form back to scientific notation. So when there's no decimal, it's the decimal at the end. And you only want one number between 1 and 9 in front of the decimal. So I'm going to move this decimal until I have one number that's between 1 and 9 in front of the decimal. So that's 1, 2, 3, 4, 5. Start right there. All right. So I got one number between 1 and 9 in front of the decimal now. So my number is 8. You can put 8.0. You won't see the 0 after a decimal, but you can put 8.0. So it's 8 times, this number was bigger than 1, so I know my exponent is going to be positive, 10 to the 5th power. All right? So that's kind of the longer way to do, but it is an option for you to do, to put it in standard form, multiply your numbers together, and then put it back in scientific notation. Sometimes that makes more sense to people. So if that makes sense to you, do it that way. Another way you can do it is if you know your exponent rules. Okay? So basically you take your two numbers and you multiply them, okay? And you take your bases that are the same and use the exponent rule that we learned in the previous chapter, okay? So this would be 3 times 3, okay? And then you would say 10 to the negative second power, 10 to the negative fourth power. Same base, we're multiplying, so we're going to add our exponents, okay? So this would be 9, because 3 times 3 is 9, times 10 has the same base, negative 2, plus negative 4. All right? So 9 times 10, negative 2 plus negative 4. So that's 9 times 10 to the negative 6th power. All right? So that would be in scientific notation. Now it asks us to write it in standard notation. So I would take my 9. When there's no decimal, my decimal is at the end. It's a negative number, so I'm going to move it 6 times to the left. So it's going to be 1, 2, 3, 4, 5, 6. My decimal will end up right here. Empty humps mean zeros. So my new number is 0.12345 This is standard notation. I'm sorry, you guys. Standard notation. You just had to move your decimal 6 times to the left to write in a standard notation. This would be scientific notation. Okay. So it's all about moving your decimal, knowing your exponent rule. So it's going back to that exponent rule. Okay. So I'm going to do number 3, and you're going to do number 4. So number 4 is for you to try. Okay. So number 3, find each product using either method. So they're basically telling you you can put it in, write it in standard form first and multiply, and then put it back in scientific notation, or you can use your rules. I'm going to use the rules just because it's quicker, and I like to use the rules because once again, it's quicker. And they want the answer in scientific notation, scientific and standard notation. So you need them in both notations. So, multiply your numbers. 9 times 2. Same base. 10 to the 5th. 5 plus 10 to the 3rd. So my final answer is going to be 18 times 10 to the 8. So this is scientific notation. But they also ask for it in standard notation. So you're going to take your 18. You got to move it 8 times to the right because this is positive. When it's no decimal, your decimal is behind your number. So 1, 2, 3, 4, 5, 6, 7, 8. That's 8 times. So my number is, every 3 zeros from the back is a comma. So that's how you write your number. Okay. So this would be standard notation for the answer. Scientific. And this is standard. Okay, so try number 4. All right, number 6 and 4 will be for you to try. Number 5, same thing. You can either write it out or you can use your rules. I'm going to use the rules. If you want to put it in standard form first, that's up to you. So 8 divided by 2 is what you would do. 8 divided by 2. All right. Which gives me 4 times 10, 8. We're dividing now. So when you divide and have the same base, you subtract your exponents. So it's 10 to the 3rd power. So this would be scientific. So 8 divided by 2 gave me the 4. Same base. We're dividing this time, so you subtract your exponents. 8 minus 5 is 3. All right, last question. You have 2.5 divided by 5 times 10 to the 3rd. Since we're dividing, we're going to subtract our exponents, minus -2. All right, so double negatives will make a positive. So that's 3 plus 2, so we know that's going to be 10 to the 5th power. So once we get 10 to the 5th power, we got to say 2.5 divided by 5, which gives me 0.5. So this is not my final answer because I do not have one number in front of the decimal that's between 1 and 9. It's a 0 in front of the decimal. So that means I need to move my decimal over 1 time. So I have a number in front of the decimal that's between 1 and 9. So this will be 5. Okay, 5 times 10. All right, so like I was saying, since you don't have a number in front of the decimal that's between 1 and 9, you got to move it back 1, so you have a number now in front of the decimal between 1 and 9, which would be 5. So since I moved it back, I got to take 1 away. I moved 1 back, so I have to take 1 away from my initial exponent because I'm moving my decimal from where it was. So when you move back, you take 1 away. When you move up, you will add 1. So I'll show you an example of that also. So this would be 5 times 10 to the 4th power. That would be my final answer. That's scientific notation. If I had to put it in standard form, you would say your decimal is always at the end. 1, 2, 3, 4. So that would be 50,000. So I just want to repeat what I said for clarification to make sure you understood why I subtracted 1. When you have to move after you solve everything and you don't have one number in front of the decimal that's between 1 and 9, you have to move it so you can. So remember, initially we only had 0 in front of the decimal. So I had to move my decimal back 1 so that now I had 5 in front of the decimal. All right. So since I had to move back 1, when you move back, you got to take back what you moved. So that means you got to subtract. That's how you can remember that. When you move back, you got to take back what you moved.